I said this is a review of angle geometry. Do we remember angle geometry?
See.
So we have some diagrams, and is the microphone on, Haley? I think it is, but can you just double check?
Phil. May you please turn the light?
Oh.
Yes, it's on.
Okay. So in these kinds of situations, there will be diagrams. Now, generally, next to the diagram, it will say this is not drawn to scale, okay, or this is not an accurate diagram. The reason being is that you must not ever measure the angle with a protractor. That's not what they want you to do. You're using geometrical reasons to establish what the missing angles are. Okay. In order to do that, we use certain rules about angles and lines. So these things. So this here, angles on a straight line, would be your geometrical reason for a given calculation. Okay, so often a question will say, what's the value of something giving geometrical reasons? Okay, so for example, this might be labelled as 110 degrees, this may be labelled as X, this may be labelled as 20 degrees. I've got nice easy numbers. And you would be asked to calculate X. Okay? They use the word calculate or evaluate because you are not measuring it. Okay? What do I know about the angles that sit on a straight line? Haley?
All of the angles together equal 180.
Be careful how you phrase it. All the angles together. How do you mean together?
Like all of them, like the sum of them.
The sum of them. Good. Okay, so I'm just going to try and push for things like that, and to make sure that you're saying it properly. So the sum of the angles on a straight line add to, what did you say, sorry?
180.
180. Okay, so we are able to calculate this because we know that 110 plus x plus 20 equals 180. So we've set ourselves up an equation using a geometrical reason. We would then join like terms, so we know that the 110 and 20 gives us 130. And to find x, we would then do 180, subtract 130. So x is 50 degrees. Now the reason we would give is angles on a straight line. You don't need to say that they add up to 180. Okay? I know that you knew they added up to 180 because you set your equation up to say that it was equal to 180. But just in case, let's make sure we've got that written down somewhere, that the angles on a straight line sum to 180. I'm just mentioning, I'm hoping it's not going to confuse you, but I'm mentioning that it has to be angles that meet on a straight line, okay? So I would always suggest to you, imagine a protractor. So are the angles you're interested in, do they stem from the centre of your protractor? Sometimes you'll get a situation like this, and someone will say, well, this angle here and this angle here, they're both on the same straight line. Well, yes, correct, but they don't meet at the same point. Do you know what I'm trying to say?
Yes.
Okay, so just make sure that you're talking about angles that all stem from the same original point. It's borderline ready.
There goes a not so smart board.
Okay, angles at a point or in a full circle. What do we know about angles at a point or in a full circle? Erin?
It's all the angles put together. So the sum of all the angles is 360.
Okay, sum to 360. Perfect. Okay, so we would know that. Do we need to write an example?
No.
I just call them A, B, C, D, E, and say that A plus B plus C plus D plus E equals 360. Okay, we're going to do enough practice that you're going to be able to work out stuff. And again, they all meet at the one place. Okay, so we know that they all add up to a 360. There could be there could be two angles that meet at three other points. There could be 7 angles. There could be 3. Whatever you've got, those angles add up to 360. Okay. This is the one that people get confused. They often miss this word here, the vertically opposite, and they will just say that they are opposite angles. Unfortunately, I would love to tell you that just saying opposite angles is okay and that you'll get away with it in an exam. The reality is that sometimes they will accept it, but other times they will not. So try and remember to include that vertically bit. Even if they are not in a vertical line, they are still vertically opposite angles. Yeah.
So what's the difference between opposite angles and vertically opposite angles?
That's what I'm saying. The official should be vertically opposite angles.
Because like they're.
What's the difference though?
Because if I had this situation here, you could say that this angle here is opposite this one. It's on the opposite side of the line.
Yeah.
Okay? But that's not vertically opposite. This would be its vertically opposite.
Okay.
Does that make sense?
Yeah, that makes sense.
So they're trying to ensure that the word opposite is not used incorrectly.
Yeah.
Yes.
So it's sort of like the diagonal line.
Exactly, yes. So vertically opposite angles are diagonals. So this one here is vertically opposite this one, and this one is vertically opposite this one.
So
Okay?
also, isn't it like the vertically opposite angles equal the same thing?
Yes, so that's what I was going to say. So what's special about vertically opposite angles? They are equal, yes? Now, with the vertically opposite angles, you can often bring in that very first reason that we talked about, okay? Because vertically opposite angles are always on straight lines, okay? So it has to be straight lines crossing. We also know that these two angles here sit on a straight line, yes? And so we know that these two angles here add to 180.
Wait.
So the green and the red
yes.
add to 180,
Yeah.
and the two red ones are opposite each other, so they're the same, and the two green ones are vertically opposite, so they are the same. But just be aware that sometimes you can bring in more than one reason within one question, okay? Yeah,
But I have a question. So
that's why you have your hand up. You don't normally need to tell me.
okay.
Always do that, Julie.
We'll just say yours better. So
I'm trying to help you abandon us to your new school, and they might think you're weird.
that's fine. I'm just kidding. Sarah, would you ever have to like guess it? Not guess, but would you ever have to have an like? Would you ever have to say the angles without knowing any? Wait, that's dumb. Never mind. Sorry.
Okay, good. You will always be given sufficient information to work out the missing angles.
So what if you're not?
Listen to the words I'm saying. You will always be given sufficient information.
Sounds
You
good.
may have forgotten how to use the information they've given you, but there will be enough there. And that's why I'm trying to make sure that you realise that if they had given you this red cross here and asked you about, oh no, that's a bad example. Anyway, you may need to use 2 or 3 different reasons in order to get to your final answer. So it may not just be a one and done. Like, so it may not just be they've given you this one and asked you about this one. Okay? There may be other things that they want you to do.
Yes.
Okay, angles of a triangle. I'm hoping you remember about the special rule about angles that are inside a triangle. Someone I haven't asked. Sydney, what do we know about angles in a triangle?
Isn't that all the sides?
Remember what about angles?
All the angles in a triangle are equal to
Careful how you're saying it. They're not equal
all
to
the
180?
angles added up.
Good.
Equal 180.
Good. They sum or add up to 180. And I am getting really pedantic about it because you can't say that the angles in a triangle equal 180 because this is an angle in a triangle. It doesn't equal 180. Okay, so you may be like, yeah, that's what I meant. But we need to try and be pedantic about it. So these angles here, the 3 angles, always add to 180 or sum to 180, whatever you want to say. Okay, isosceles triangles. What's an isosceles triangle?
It's an equal base angles too.
Nice. So they. But what makes something isosceles? Was where I was going with my question.
When the two sides like line apart, like
Two of the sides are equal to each other. Yes. So this diagram here should have some kind of marking to show that those two sides are equal, which means that these ones here, these angles at the bottom, they're called the base angles. They would be equal to each other. Okay. So if you know this one on the left, and you're asked to find this one at the top, you know that the one I'm pointing on the left, I'm saying left and I'm pointing on the right. So if you're told this angle here, you know this one's the same as it, and therefore you can find the missing one at the top because you know they all add up to 180. Okay? Yeah?
So this diagram was supposed to have those little lines,
Yes,
but it didn't.
it didn't. I do apologise. My notes were shocking.
So what if that happens on the test?
It won't, darling. Okay. I will ensure on the test that everything's
Got it.
so if a triangle looks like an isosceles but it doesn't have those lines, then it's not an isosceles.
correct, yes. Unless they've said in words. So for example, if they said this is A, B and C, and they've said at the top, which I know you lot are pretty rubbish at reading the bits of information at the top, they may have said that AB equals BC. So they may have given you that information, which tells me that I know these two lines are equal to each other. So they may not have markings on them, but they've told me this. So that tells me that those two lengths are equal to each other. So you've got to be careful that you're reading the information that you are given. It's there for a reason.
Thanks for the more complicated. But will this be on the test?
Your test coming up? No, it's just going to be on the stuff that we...
Which is ratios and proportion. Like the stuff in the book.
Ratios, proportion, and speed,
Distance, time.
We can memorize those triangles.
and the pressure triangle. The pressure.
What's the pressure triangle? Well, you should. You should already know that. So it's just distance.
Just look at the notes.
Just distance over speed and time.
It's like this. How about this? Right. Shh. So it says here at the bottom. Remember, when asked to calculate or work out the size of the angles, you don't use your protractor to measure them. You also need to learn the reason for the angle being the value chosen, because that's going to be awarding marks. Sometimes you may get the answer correct, so you may say that the missing angle is 27, but if you haven't got the correct reason, you get nothing. Okay, so you may think it's a bit harsh, but you do need to make sure you've learnt those angle reasons. Okay, and as I said, sometimes you need to give more than one reason. Right, so this is a page here with a few of those different types of things on them. I'm going to give you a bit of time to work on them, and then we can start putting the answers up. Could you please write the reason for each of them as well? Okay. So if we're trying to find the missing angle B here, tell me for a start which reason are we going to use? The reason should be the first thing you establish, because that's how you link.
All of the angles summed up equal 360.
So so that was the angles at a point. Yes.
Angles at a point.
So that would be our reason for this one. So angles at a point, and then you can tell me what B is, because you're going to add these ones up and then subtract that from 360.
So you could say like, B is blah blah because the angles are at a point.
That's right. Yeah. Okay. So you girls get on with that. Right. Okay. I probably should know the answers to these, but I'm going to trust that you will get brief responses. What's B?
B is 163.
And what was the reason?
Circle.
Angles at a
Angles at a point add up to 360.
Okay. So you can just say add a point.
What?
What was D?
D
62.
is 62.
And what was the reason?
Straight line.
Angles in a straight line.
Straight line. And this one?
Angles on a straight line.
Okay, so A is 37, and that was straight line, good. And
70
B is 70, what was the reason?
on a triangle.
Angles in a
Triangle. Triangle. And usually when there are two different letters that they're asking you to find, you'll be expected to do them in alphabetical order. So A, you should need to find before you find B. Not always, but usually, often. They didn't have a letter on this one. What was this bad boy?
X. Well, that one equals, sorry, 119.
Yes,
And what
ma'am.
was the reason?
Angles at a
angles
point.
at a point.
Good, at a point.
Is it okay if you said circle?
I personally don't like circle. Can we try and go for angles at a point? You in a full circle, maybe you might get away with, yeah. And E.
Angles at a vertically
No.
opposite. Vertically opposite angles are equal, and then angles on a straight.
Angles on a straight line.
So one of them has to be on a straight line first, okay? So if we're going with the let's go in alphabetical order, if we're going E first, then that would be the straight line. And what would that be?
E was 122.
Now we can do F would be
Vertically off.
Vertically opposite are equal.
and that's 122. And then G can be
Vertically off.
Vertically opposite.
opposite, or it could be angles on a straight line as well, yes? And that's obviously 58. Okay, Trisbians?
Yeah.
A, what would A be?
A equals
65.
65.
What would the reason here be?
I saw
We talk about this.
50.
angles in a triangle. I saw angles in an isosceles triangle.
The base angles are essentially triangles are equal.
Yeah, that's a beautiful answer. So you probably only need to say base angles of an isosceles triangle, okay? But you do need to mention the fact it's an isosceles triangle. So I would say base angles
In a isosceles.
of isosceles triangle.
But you don't have to mention it base
You don't need
angles.
to say that they are equal. You don't need to give that reason,
Okay.
okay? And then B would be what?
Angles
50.
And what would the reason for that one be?
angles at a triangle.
Angles in a triangle, add a sum of triangles,
Come on.
yeah? Okay, and you don't need to mention that it's an isosceles triangle at that point because you've already worked out that missing one there, yeah? Last one. Oh, well, there's millions of them. A, so what's A?
57 degrees.
Okay, it's 57, what was the reason for that one?
Angles on a straight line.
Good, straight line. Let's go with the alphabetical order. So B would be,
86.
and what was that reason?
Angles in a triangle.
Angle sum of triangle, yeah. Okay, and then C would be,
123 degrees.
and what's the reason?
Vertically
Vertically up. And D would be,
D would be
you got loads of reasons.
Vertically
vertically opposite.
Okay, so D you can have vertically up, you can have straight line. Okay, and that would be 57 as well. Yeah.
57.
Oh, that doesn't look like 57, doesn't matter. And then E would be
E would be angles in a triangle at to 180, so it'd be 110.
angle sum of triangle. Okay, perfect. Get the idea?
Yep.
I think let's find some facts for these. So parallel lines. So these are important because they tell us about, again, there's special features of parallel lines that talk about the angles. So we know that parallel lines are lines that what?
Are parallel to each other.
Keep going. They never break.
Nice, Lily. They never meet.
Alright.
Okay, lines that should rest on that. Parallel lines are lines which never meet. Okay, they are usually shown with arrows on them. Okay, they would normally, the arrow would go through the line, obviously. Might walk through the line. Okay, so parallel lines are lines that never meet. Okay, I don't. I'm sorry. I went there, and I know that's not what I want. I would say, the official. Oh my gosh, speak English, Miss Harrison. They are the same. Oh my god.
Oh, which are they?
Yeah.
Oh my god. They are the same distance apart is what the official definition is. Jesus Christ. Okay, so parallel lines never meet, but the official reason is that the official definition is that they are the same distance apart. Okay, so parallel lines are always the same distance apart. Jeepers creepers. In any diagram looking at angle geometry, sometimes there will be parallel lines involved. Okay, so if there are parallel lines indicated with arrows, then it means you're going to probably be using one of these reasons. So there are alternate angles. Do you remember alternate angles?
No.
alternate angles?
Okay, so here's two parallel lines. Okay, these are my parallel lines. They're showing that because they've got arrows on them. This line going through that is a fancy word called a transverse line. Okay, a transverse line. So that line there goes through it. If you've got a line that goes through two parallel lines, it means that if you have an angle here and an angle here, those two angles would be equal to each other. Okay? So they are on alternate sides of the transverse line. Okay, so they're on alternate sides of the transverse line, but within the parallel lines. Okay? So these are equal. That looks like I said transverse line.
And the one across
Alternate
there.
angles are equal. Now, obviously, if you've got those two angles are equal, we also know that these two angles here
Are
are
equal.
also equal because they are on alternate sides. Here, I'm talking about this one and this one because they're also on alternate sides.
Wait, and then also the one across. Whoa.
Now, it has to be within the parallel lines. So we can't be talking about above and below, okay? It's got to be within the parallel lines. Do you understand what I mean by that?
Yes, ma'am.
So if you're bringing those two parallels together, those two angles have to squish together. Stop TikToking.
Not you guys, not me.
Right, so if I know that this angle here is 110, and I'm asked about this one here, I know that that one would also be 110, and they are alternate angles. Okay? That's all you have to say, they're alternate angles. Trismians?
I have a question.
Yes.
I'm still confused about why the other one wouldn't be.
The other one.
Sorry, hold on. I wrote equals instead of angles. Okay, why the vertically opposite one from the vertically opposite angle from that.
Oh, well, no, okay, well, sorry, I apologise. So there are other angles in this diagram that are equal to those, okay? But the alternate angles
Okay.
are the green ones or the black ones.
And
Yeah.
those ones really on the opposite. Sorry.
Because they're on alternate sides of the transverse line.
And alternate means like.
Kind of like opposite.
Okay.
Okay, but then also,
Stop it.
so you said that the one next to it is also the same.
No. I said that the two green ones
Oh, that
would
makes
be alternate to each other.
Yeah.
And the black ones are alternate to each other. Yes? Okay? But they're not all alternate angles. Yes? Only pairs. They're alternate pairs. Okay? Is that all clear?
yes.
Corresponding angles. Corresponding angles. And again, here are my parallel lines. Okay, they've got the arrows on. There's my transverse line. Corresponding angles hang from the parallel lines on the same side of the transverse line. Okay? So if you can see that they're both on the right hand side and they hang down from the parallel lines. Okay? So they are also equal. Now I've done 3 other diagrams because we've got several other pairs of corresponding angles. We could also have these angles here. They would be corresponding with each other, so they would be equal. Now we've had those 2 sets are hanging down. Obviously, well, I say obviously, you could also have them above the parallel lines. So we could have these 2 would be corresponding angles, and these 2 would be corresponding angles. So the red ones are hanging down, the green ones are hanging down. The blue ones are going above, but they're on the other each side. Okay, so the corresponding angles are on the corresponding or same side of the transverse line. Okay?
Sorry, can you say that again, please?
So corresponding angles are on the same side of the transverse line.
Okay,
Okay, so the red ones are both on the right.
yeah, that makes sense.
Okay. Yes. Now, in some cases, you may be told that sometimes people say these are F angles because it kind of makes an F shape.
Oh yeah, I've heard that before.
Now, my reluctance to talk about the letter is that in an exam you will get nothing for saying they are F angles. Okay, you have to say they're corresponding. So I'm taking a step back. I'm telling you what the letters are because I don't want to confuse you. Right, the other type with regards to parallel lines are co-interior. Okay, now these are not equal. So the other two sets were both equal. These add
To 180.
to 180. Okay, and co-interior angles are angles that are surrounded inside the parallel lines, but on the same side of the transverse line. Okay.
Can you have like angles that are opposite the transverse line? So like on the exterior bit of the parallel line, like outside, so like the opposite, so like on the other side of the line of the
Do you mean the alternate angles that we did first?
No, like on the other side.
Come and tell me what you're talking about.
Like here.
They don't have a special name. You would need to use other reasons to get to those. Okay? Alright, so they would be co-interior angles, and these would also be co-interior angles. Okay? But they add to 180. They are not equal to each other. Yes? So we get the gist of it?
Mm-hmm. What if angles are adjacent to each other?
Then that would be angles on straight lines.
Oh yeah.
Yes?
Okay.
So, those old chestnuts that we've just learned or reminded ourselves about, they hold true no matter what. Okay? So if you've got here that you've just worked out this one here, you know this one here because they're vertically opposite each other. Yes? So those other angles reasons that we just talked about apply to these as well. Yes? So your straight line is your good old fashioned, that's going to happen a lot. Your vertically opposite happens a lot, but the parallel line ones come into play often as well. Yeah?
But these, they add to 180, but they're not on the same point. Like in the middle.
Correct. And that's why, so this is a specific reason because these lines are parallel. So if you had a situation where you had two lines like that, this one and this one would not add up to 180. Because these lines here are not parallel to each other. Okay? This one and this one add up to 180 because that's a straight line. Okay, so that rule always holds true because they do meet at this point, and that's what I was talking to you earlier about. But this is a prime situation. If you had a diagram like, if you had this diagram like this, people say, oh, those two angles are on a straight line. They add up to 180. Okay? They don't, because as you just said, they don't meet. But this one is a different rule. This is that they are co-interior angles. And that only is the case because those two lines are parallel to each other.
Okay, so even if they don't meet at the same point, since they're parallel, that means that they add up.
Yes. So they could. So So maybe when I said that, I should have been clear that majority of times they would. If they are parallel lines, then that's a different reason.
Mm-hmm.
So you would not say that. You would not give the reason that they are on a straight line. Okay.
Mm-hmm.
Yes, you would give the reason that they're co-interior. Yeah.
Yeah.
Okay.
So do all the angles, so like say on the left side of the transverse side, would all the angles add up to 360?
Well, in this case, because there's only two lines, yes, but you could have 17 lines, so I'm not going to say what they would always add up to, but you know that if there's a straight line, then the angles that reach that point add up to 180. Okay? All right? Oh, and then I think I've done some more of these. Yes, so have a go at some of these ones. There's lots of different, and you need to give reasons for those too.